Those 15 minutes went by way too quick and we didn't cover enough material, so I'm going to try to speed it up. So they give this angle theta, and it's the angle through which the plane turned. And they tell you that it turned 27 degrees at this point to north, 27 east. And if we go back to our understanding of bearings, we always start at a north-south axis, and you turn this way until you get to 360 degrees. And anything in this side is going to be northeast. Anything this side is going to be southeast. Anything in this side is going to be southwest. This side is going to be northwest. So this is north and 27 degrees east. That makes this angle 27 degrees. 27 degrees. And this is a right angle. You can just draw this in. And so now you have this whole angle. So if we add up 90 degrees, which is the right angle, and this left other angle, you get 90 and 27, which is 117. And that's your angle right here. So now you're again, you can use law of sines. So sine of 117 over 227 is equal to sine of, let's give this angle a name so we don't get confused. We're going to call this alpha. So sine of alpha over 160. Sine of alpha is equal to times 160 on both sides. So then arc sine again, alpha is equal to arc sine 160 times sine of 117 over 227. And then if you plug that into your calculator again, you get alpha is 38.9 degrees. Now we're not done yet. Alpha is just this angle in here, and because it's a line, we know that it's 180 degrees across. So to find theta, we simply find 180 minus 38.9, which is 141.1, and that's your theta. So theta equals 141.1 degrees. Okay, moving on. Question 6. Okay, so parallelogram, and you're going to have to excuse my art skills as they are a bit rudimentary. So we're given this parallelogram, it's diagonal. Okay, and they tell you that this angle is 39 degrees, and the side length is 10.8. and the side length is 9.4, and they want you to find the length of the diagonal. Okay, and they tell you to use law of cosines, so law of cosine. So now if you're given that one angle of a parallelogram, that's 39 degrees, you can this angle right here is actually going to be the supplement of this. This is some geometry stuff, hopefully you remember. If not, well, you're learning now that it's the supplement. So 180 minus 39 is again, look at that, 141. So this is 141 in there, 141 degrees. And you're given a side opposite an angle, and you're given the two other sides. That's one of the cases. I think it's side angle side. And that's where you can apply the law of cosines, where it says this unknown side c squared is equal to the sum of the squares, 9.4 squared plus 10, minus 2 times the side lengths, the product of the side lengths, times the cosine of the opposite angle. Okay, so really this whole thing, so c squared is going to be equal to, plug the whole thing into your calculator, I guess, or into parts, whatever works for you. So you get c squared is equal to 362.79, and then c is equal to the square root of that, which which is 19.05. Right, yes. And that's all you're looking for. Moving on to question 7. Okay, question 7. Another diagram, look at that. So 330 yards, 19 degrees in here, and 215 yards. And they want you to find this side. I'm going to call it X. Okay, there's a story behind this which is totally useless. So they give you this thing and it's the same situation as up here. You're going to use law of cosines again. So x squared equals, oh, and like all these variables I'm using, x, z, or whatever, or alpha, whatever I'm saying, they're all just whatever variable you want to use, so you don't lose track of what you're solving for. Okay, so x squared is equal to 215 squared plus 330 squared minus 2 times 215 times 330 cosine of the angle you're given. And then x squared is equal to 20955.91. And then x, if you take the square root of that, is approximately equal to 144.76. And then they say round to the nearest 10, so 144.8 yards. Don't forget that, because he might mark you down for that. Okay, so that's how you do that one, using law of cosines again. Question 8. Heron's area formula. That's not a right angle. So, if you're given these two sides, a third side, and they tell you the perimeter is equal to 29.3. So perimeter is 29.3, and they want to use Heron's area. This is the second formula they're given, Heron's area formula, which states area is equal to this square root of this s times s minus side 1 times side 2 times side 3. And yeah, it's a long thing. I don't really want to write it out, but so s, which they use in the formula, is equal to the sum of the sides, or the perimeter, divided by 2. So perimeter divided by 2. So you're given the perimeter. So 29.3 divided by 2 is 14.65. That's your s. So s equals 14.65. And you want to use that in the area formula. So the area equals s times s minus side length 1, which is 8, times s minus side length 2, which is 8 again, and s minus side length 3, which is w. S minus w, and taking the square root of that. And then w is really just the perimeter minus the sum of the two other sides, because that's how you get perimeter. So 8 plus 8 is 16, and the perimeter is 29.3, so w is equal to the difference of those two, which is 13.3. So the area is equal to s, which is 14.65 times s minus 8, which is 14.65 minus 8, times 14.65 minus 8, times 14.65 minus w, which is 13.3. This is the square root of this whole thing, and area is equal to 29.57. And that's the area of this triangle using Heron's area formula when you're given the perimeter on these two sides. Okay, so 9. Fun. That's 9. So moving from triangles to vectors, which happen to be closely related. So in a coordinate plane, you're given these two vectors, vector u, which goes like this, and vector v, which is somewhere down here, like this. And I'm not going to draw out the whole coordinate plane, but you can look at it yourself and count the location of the initial point and the terminal point. So if you count those, u is negative 3, 4, 2, 1, 0. So the vector starts at negative 3, 4 and goes to 1, 0. Negative 3, 4, 2, 1, 0. And that's vector u. Vector v similarly is here, which is negative 6, negative 6. 2, negative 2, negative 10. And then you want to show that u is equal to v. Okay, so in order to do that, you have to show that the magnitudes are equal. Sloppy, and you want to show that the direction angles are equal. So first, I would suggest putting them in component form, which is much easier to work with. So component form is terminal point minus initial point, and that's how you get the component form. So 1, 0, minus negative 3, 4. So 1 minus 3 is 1 plus 3, which is 4. 0 minus 4 is negative 4. So vector u in component form is 4, negative 4. And these, I guess, spiky parentheses, or this less than and equal sign, or less than or greater than sign, are used to designate a vector to differentiate from a regular point. So this is u at, this is the component form u. V, again, terminal point minus initial point. Negative 2 minus 6, negative 2 plus 6 is 4. Then negative 10 plus 6 is negative 4. And so you see that these two vectors are equal, but you have to continue proving them. So magnitude of v and magnitude of u have to be equal. So magnitude is really just applying the distance formula. So square root of 16, which is 4 squared, so square root of 4 squared plus negative 4 squared. So 16 plus 16 is square root of 32. And I'm not going to simplify it, it's not necessary. V, that's u, and v, same number, so you do the same thing. 4 squared plus negative 4 squared, square root of 32, and those two are equal. Magnitude of u is equal to magnitude of v. Then direction angles. Direction angle you do, so for direction angle, you know that the tangent of the direction angle is equal to b over a, where b is the y value of the vector, and a is the x value of the vector, or the I and j components. And to find that, so you know the tangent of the angle is equal to b over a, so the angle itself is equal to the arctangent, b over a. Arctangent of b over a is arctangent of negative 4 over 4, so arctangent of negative 1. And the arctangent of negative 1 is negative 45. But because we have to do it in positive angles, you just simply add 360 there, because negative 45 will fall somewhere in here. And to find that, you have to go all the way back around, until you get here again, which is 360 minus that, which is 315. And you do that for both of them, and you find that those angles are equal. And that'll be the end of part 2.